Now we have taken a binary classification problem. Here there is an image. We want to detect whether in this image cat is there or not. If our learning algorithm finds the cat, then output should be 1. If our learning algorithm does not find the cat, then the output should be 0. This is what we expect. For that, we are taking the binary classification as the name. Binary is representing 2. The output is either 1 or 0. 1 is a positive class, which is telling there is a cat in this image. 0 is a negative class, which is telling there is no cat in this image. This is a classification problem because the output is fixed and it is discrete. As we have considered color image, we already know any color can be represented by using the primary colors red, green and blue. So this image I have considered a 64 by 64 pixel image. What is a pixel? A pixel is the information in one rectangular block. So in this image we are taking 64 by 64 rectangular blocks. For your understanding, I am drawing that picture, and here I am taking the 64 rows and 64 columns and 64 rows. So each rectangular block information can be represented from 0 to 255. So the maximum value can be 255 and the minimum value is 0. So this is a 64 by 64 pixel image. Because this is a colored image, now I am representing that by using a red colored 64 by 64 and green colored 64 by 64 image and blue colored 64 by 64 image. What this 64 by 64 matrix, this red color matrix is telling, in the each rectangular block, this red color matrix is showing how much the amount of the color redness is there. Whenever the more redness is observed, then the value is reaching towards the 255. When the redness is decreasing, the value is reaching towards the 0. So that's how we have the matrix 64 by 64 matrix for the red color and for green color and for blue color. Even though we have considered only one image, because this is a colored image, we are representing that by using a red, green, blue. Now if we ask the question again, finally how many values we are getting? For red color, we are having the matrix 64 by 64. Again for green color, 64 by 64. Again for blue color, 64 by 64. What we are really doing? We are taking one particular block, and in this block we are checking what is the amount of red color is there, what is the amount of green color is there, what is the amount of blue color is there. That's how we are taking that colored image. Now finally we are having 64 by 64 by 3 boxes, rectangular boxes. So totally 12,288 rectangular boxes are there. Now I want all these rectangular boxes information. Remember, in each rectangular box, the information is either from 0 to 255. I am representing that color by using a number. That number may vary from 0 to 255. Now I am taking all those 12,288 values in a single column by using a matrix X. This is our input. So when I am giving this input X, what we are really giving to the learning algorithm, we are really giving a 12,288 values. These 12,288 values, in each and every value, the value must be either 0 or in between 0 to 255. So we have considered X matrix. I am dividing it into three parts. In the first part, these are the values, 64 by 64 values that are unrolled into single column. So these are 64 by 64 values of a red color image, and this is 64 by 64 values of green color matrix, and these are 64 by 64 values of blue color matrix. So all these 64 by 64 12,288 boxes values now are represented by using a a single column. The matrix size of X is now 12,288 by 1. If you remember, in the machine learning, we have discussed, we are telling each value, we are taking each value as one feature. Now, how many features are there here? 12,288 features are there. Because there are 12,288 features are there, we have to consider 12,288 parameters to design the model, that we will discuss later. As of now, if you are familiar with this notation, that would be okay. For the, if you if you don't have the familiarity regarding these terms, then we have to take look regarding these terms before we go into the cost function. This X, this is the image we are giving for the training. Now, as of now, we have already understood this X is a matrix 12,088, a matrix with 12,288 features. Now, Y is the output. The output of Y is either 0 or 1. Only two values are there. It is either 0 or 1. So this is a binary classification problem. And what is the input X we are giving? It is a matrix which is having 12,288 features. So 12,288 by 1. Now, instead of telling 12,288 every time, my image may be 64 by 64 pixels or 100 by 100 pixels. What if it is of 200 by 200 pixels? What matters to me? So now onwards, I am not calling again 12,288 features. Now I am taking as n features. So these n features are nothing but we are multiplying the rectangular boxes, the row rectangular boxes and column rectangular boxes, and finally we are getting n. So this n is how many rectangular boxes totally are there after adding this R and Z and B. After adding, and we are unrolling all the values into a single column, that is given by n. In the previous example, this n value is 12,288. So if we give 100 examples, 100 images, in each image we know whether in that image cat is there or not. In the first image, if I know if cat is there, then output is 1. In the second image, I have given only an image which is consisting of nature. There is no cat, so output is 0. In the mth image, there is a cat, so the output is 1. In each and every image, we are giving n features. So the matrix size of each training sample we are giving, because it is having n features, so the matrix size is n by 1, n rows and 1 column. For every training sample, this is the second image, matrix size is n by 1. This is the mth training sample, matrix size is n by 1. So as of now, computer does not know as that as an image. Computer is simply seeing it as a matrix, even though you know it is an image of cat. But as of now, our learning algorithm knows only it is a matrix of values, n rows and a single column. Finally, if I have taken the 100 examples we have discussed already in the machine learning, when we are training, we should not give all the 100 training samples. We have to keep, for example, in the ratio of 60 20 20, 60 images for the training, 20 images for crash validation and 20 images for testing. Example, if I train my learning algorithm with 60 training samples, now my learning algorithm is ready to detect whether in the new image cat is there or not. It is like we are training a small child with 60 words, maybe with the 60 examples. I can say with the 60 examples I am training a child how to tell yes and no. Now the child is ready to tell yes or no. If we give a new incident to him, if we create a new situation to him, he has to tell yes or no. This is a classification problem. Now we are checking, that is what we are calling as a crash validation. And finally, if the results in the crash validation, when we are checking with the crash validation set, if the results are very good, then we will proceed for the testing. If in the testing also the results are favorable, then our learning algorithm is ready to predict. You may give 1 crore images, our learning algorithm is ready to detect whether this image is a cat or not. So that's why we are writing mtrain, means the training images, test images. As of now, we are not discussing about the test images. We are continuing about the training images. So this is the X superscript 1 first image features. How many features are there? N features are there. So first column, in the first column, how many rows are there? N rows are there. This is the second image. How many rows are there? N rows again. This is the mth image. How many rows are there? N rows again. So this capital X is the matrix which is consisting the features of 100 images, or if I take that as a m images. So the matrix size of this capital X is n by m. This n is representing the number of features. This m is representing the number of training samples. In this example, for your convenience, I am telling with the numbers. If I have given 100 images, then this number is m is equal to 100. If I have given 12,288 pixels, so are 12,288 boxes, I have to say. I should not use the word pixel because only it is 4 by 64 pixel image. 12,288 boxes, the 12,288 values, I can say. So it is the matrix with 12,288 by 100. So finally, our capital X is ready. This is the matrix which is consisting of all training samples. We have given m training samples. Each training sample is an image which is consisting of 64 by 64 pixel image. So we have taken RGB values, means 12,288 values. Now all these 12,288 values we have considered in one column for the first image, second column for the second image, and mth column for the mth image. Now all these columns are including the features of our images. So the capital X matrix size is n by m. That's what we have discussed. Now you may get the question, instead of taking all these features of first image, we are having 12,288 features. Can we take all these features in the one row, x1 transpose? This notation should not be used as of now, because in the neural network we are progressing the logistic regression in such a way that we are learning the concepts which we will apply in the neural networks. When we go into the neural networks, the convenient way to represent, the best way is to consider all the features only in one column. So we are taking all the features in the one column, and the output is either 1 or 0. Because we have given m training samples, so the final output is, it is m by, so only one row and m columns, so this is 1 by m. In the Python, we will use x dot shape n comma m, because n rows and m columns. Y dot shape output 1 comma m, which is having one row and m columns.